Come learn about cloud simulation with 3D Experience. Join our SIMULIAworks experts, Michael Steeves and Omar Zohni, in the next episode of Exploring 3D Experience Works. Why?
Hello and welcome to another episode of Exploring 3D Experience Works Live. Thank you all so much for joining today. Very excited to have you on for this very special presentation we have prepared for you today. I'm sure you guys are all familiar with my co-host Gian by now. Before, let me just introduce myself. My name is John Martirano. I'm an industry process consultant out of Dassault Systems Solidworks in Waltham. Rocking the home office today, still, as most of you are. Gian, go ahead and introduce yourself.
Hey everybody, my name is Gian. Same exact credentials and everything as John, so I'll save you some time. Let's talk about today's session. So it's going to be a little bit different as we introduce some cloud simulation on the 3D Experience platform. Pretty exciting. So usually, if you've been with us before, John and I will usually go through a design workflow with some project management or collaboration tools built in. But as you know, design is just one piece of the puzzle that is product development. So after we create a design, we need to be able to validate that we're not going to experience some type of unexpected or premature failure in the field. So we need to be able to simulate our designs, and we need to be able to go back and forth with our design engineers so that they can make the changes that they need. And maybe you work for a company where your engineers kind of wear many hats, and they are both the analyst and the design engineer. That's 100% possible and very likely here. So that's kind of what we're going to be looking at today, a workflow that shows a lot of different capabilities of simulation while also showing you how, it's still compatible with a lot of other products that we have on there. And your design engineers and analysts, if they're different people, will be able to seamlessly collaborate and design together, really. So with us today, I'm very, very excited to introduce the Simulia functionality on the platform with the Abacus solver. So if you know anything about simulation or Abacus in general, you'll know that all of the simulation products that use the Abacus solver are very, very powerful. And here to actually show us a little bit about those tools are our Simulia experts, Omar Zohni and Michael Steeves. And Omar is going to be taking us on a tour of some of the functionality included in Structural Performance Engineer. And then Michael is going to show us some of the Structural Mechanics Engineer. So with that, Omar, go ahead and take it away.
All right, guys, thanks. Welcome to the home office. Let me just turn off my webcam and share my screen here. I am going to assume everyone can see my SolidWorks screen. I'm going to give you guys a little bit of background here to start. So first off, again, thank you guys for giving us the opportunity to present today. I'm going to start with a little bit of background here. It's probably going to be redundant to some of you, so I apologize. SolidWorks, which I'm sure everybody on the call is familiar with, is a brand inside of Dassault Systems. Simulia is also a brand, and Simulia is responsible for the development of all the simulation tools we have at Dassault. So even the desktop SolidWorks simulation tools are developed by the Simulia brand, and that includes their what included in the Simulia development is kind of their flagship product Abacus. So SIMULIAworks is basically a collaboration between these two brands, and the intent here is to really provide additional simulation capabilities to the SolidWorks user community. So a little bit of history here. This timeline kind of highlights the acquisitions around simulation that Dassault has made in the last 20 years. And the reason why I show you guys this, I want you guys to understand like Dassault's long-term and deep commitment to simulation and simulation technology. So you see things from fluid dynamics, obviously FEA, magnetics, acoustics, topology optimization, failure and fatigue, systems analysis. It really covers the gambit of what you would need in a simulation suite. And these acquisitions, along with kind of the R&D vision of creating like this multi-scale, multi-physics technology, are really the driving force behind Dassault Systems and the Simulia brand. Now, I point this out because I think it's, again, it's really important for you guys to understand the breadth of the Simulia offering. The initial collaboration between Simulia and SolidWorks is really focusing on around the Abacus solver, but it's really easy to envision more tools and more physics capabilities being added to the SIMULIAworks portfolio, and allowing us to address more of the needs of the SolidWorks community. So I would argue these are probably the 8 building blocks around simulation, and you guys can see again just some of the acquisitions and development that Simulia is responsible for in these different areas. And there's a lot of really powerful tools, and I point this out because I want you guys to know, right? If you're looking, to do some of these analysis, please take a look at Dassault Systems, and please take a look at Simulia, right? Because there's a lot of power under the hood. So let's talk about a little bit about now expanding the kind of SolidWorks simulation. Now, I don't love this slide because I came from SolidWorks Desktop, and I would argue that SolidWorks Simulation Premium and the desktop offering are not just for simple physics. There are a lot of advanced types of analyses that you can do with SolidWorks Pro and SolidWorks Premium. But I would argue that if you use SolidWorks Simulation Premium and you're doing really large deformation, large strain, complex material models, models with a lot of contact, that there are oftentimes that you either can't get a solution, it requires a lot of tweaks to the solver to get a solution, and your runtimes might be really excessive. So there are, it does hit its limits. And, if we're being honest, there are just some situations where the desktop SolidWorks Simulation Premium offer just hits its limits. Now, the alternative to that, at least in the Dassault family, is the Simulia offering. And if we're just kind of looking at, let's just focus on finite element analysis now, really Abacus, there's nothing in that space that Abacus can't do. It's an extremely powerful tool. It's got really advanced material models. It's the solver itself is written to take advantage of multiple cores, so it can be really fast. So what we've done is we've added SIMULIAworks. Now, SIMULIAworks does not have all the capabilities of Simulia. What it does have is a subset of the capabilities. It's using the Abacus solver, and it's really geared towards the SolidWorks user community. Now, that being said, it's also on the 3DEXPERIENCE platform. I'm assuming if you guys have been on some of these presentations in the past, you know a little bit about the platform. It's collaborative in nature. It's on the cloud, so you can utilize cloud computing if you like. It's just got a lot of tools and apps that are very well designed. And the platform itself is a very intuitive piece of software to use. Now, I would argue that these are probably the situations where you would want to consider, at least if you're just looking at simulation, why you'd move to the platform, and specifically why you would move to SIMULIAworks. I would argue these are some of the underlying, the key things that problems that SIMULIAworks can solve. So again, problems with large strain. Explicit Dynamics is something that we couldn't do in the past. The damage modeling and the ability to do like element deactivation. Hopefully, I think Michael's going to show a little video of that. Really advanced element formulation. So for instance, if you're doing hyperelastic modeling, there are some really cool element models. The way it handles contact, some of the advanced meshing capabilities, it's a really powerful tool. Now, that being said, here are the current SIMULIAworks products offerings. So Simulation Collaborator, I would argue, not really a simulation role. It's more for reviewing and comparing different analyses. Structural Designer is kind of the low end, kind of the basic analysis product offering. So if you're just doing linear static thermal analysis, frequency, this is a great tool. Again, using the Abacus solver. What we're going to focus on today is Structural Performance Engineer. That's what I'm going to be looking at. So that does nonlinear statics. Really powerful way that it handles contact. It can do really complex material. Michael is going to be showing Structural Mechanics Engineer. To be honest, that one is a lot more attention grabbing. So you guys will love what Michael is going to show. That turns on kind of the dynamic capabilities as well as the damage modeling. All right. So that being said, let me pull out of PowerPoint and come into SolidWorks and then go over to the platform. So, oops. Let me start here in SolidWorks. So here's the first model that I'm going to look at. Now, let me give you a little bit of background about how what we're trying to do here. So we are trying to basically rotate this gear 360 degrees and figure out the torque requirements that, to achieve that. Now, what I'm going to point out is if you zoom in here, what you see is there's some initial interference between the gear teeth. Now, if we were going to solve this inside a SolidWorks simulation, first we would resolve the interference fit, then we would apply the rotation, but it would require specifying contact pairs where the teeth are interfering, as well as the contact pairs for the teeth as they're rotating, right? So, this face is going to come into contact with this face with this one. There may be some easier ways to do that, but that's kind of the steps that you would probably take inside a SolidWorks simulation. When we pull it over to Simulia, we don't have that requirement. So there's a huge time savings just in the sense of contact. Now, I'm going to go ahead and pull this over to the platform right now, but I want to point out there's kind of a couple ways. There's probably more than two, but because you could also go to a neutral format. But probably the most robust way to pull it over is to utilize the new 3DEXPERIENCE PLM services, which gives you a little bit of PLM control, so a little bit of revision control on the platform. So you can see if I wanted to, I could just click my compass here and then pull this model over into the platform. Now, the nice thing about doing that is you can see that this is called Rev 1. If I came back in here and wanted to make some changes to the gear teeth or maybe the size of the key in the middle, I could do that, make it a revision B1, and then I could update it on the platform and save both my A1 and B1 revisions. So that's kind of the more robust way. The alternative approach is just import the SolidWorks model. You still have control, so it's still linked to the SolidWorks model. So if you did make a change, even doing just the basic import on the SolidWorks side, you could do a SolidWorks update on the platform. So I think that's the approach that I used for this guy. Although I might have used PLM services, it's not really important for what we're going to be talking about. So I don't want to get into the weeds or a lot into the weeds, but let me just highlight a couple things. First, the feature manager here kind of it's something you can use to kind of walk through and set up your model, or at least review the model as it's set up. So what you'll notice is I've specified a contact initialization, which basically goes through and looks for any interfering faces, and then I don't have to set up contact pairs here. So I do, for the interference, have to identify which faces are interfering with one another. In my general contact, then I flag those interfering faces and say that I want to run a initial contact initialization, which will basically resolve the interference first, and then I apply my rotation. So this is a two-step analysis. I don't have to specify any contact pairs. The solver knows that as this thing is rotating, that any faces that come into contact are going to be considered no penetration contact. I've specified a coefficient of friction of 0.1. And really the setup is just very, very simple. So let's take a look at what the results look like. So again, I've run this as a two-step. Sorry, let me go to the results first. I've run this as a two-step analysis. The first step resolves the interference. The second step is going to apply that rotation. So I should have come up with a more creative name for my first step, since that's my interference step, but I'm just calling it static step 1. If I zoom in here, let's take a look at exactly what is getting resolved there. So if I look at the start of the step, we can see that I've got my interference. At the end of the step, we can see that my interference has been resolved, right? And there's also some plastic strain that gets generated. So the material model that I'm using here has got plasticity defined. And now I can go ahead and apply that rotation. So those first few steps were just resolving the interference, kind of at the beginning here when you see it not moving. That's just resolving interference. Then we're applying that 360-degree rotation. We can see the plastic strain that gets developed in those gear teeth as it's rotating. We can also, you've also got the ability to plot lots of other characteristics, right? So von Mises stresses, deformations. We can see the von Mises stress is pretty high in some of these areas. That's where it's contacting the teeth. We can look at contact pressure. So we can see that contact pressure. This is a relatively coarse mesh, so that's why the results don't look as great. But obviously, you could refine that mesh as you see fit. So I think when we started, we were saying we were trying to get an estimate for the torque. What I've done is I've applied some couplings in the center that allow us to really, really easily grab, the results for that for torque. So we can see the torque versus rotation. Trying to size the motor and be a little bit above, maybe around 60 Newton meters, a little bit above, to achieve the full 360-degree rotation. So that's the first case. Let me pop over into the next case. So this case is just meant to mimic a honeycomb structure. So let me go to the model real quickly. And I'm going to turn off my finite element mesh. So, and give you a little bit of background. So basically this thing is fixed around the outside, and then in the center there is a device that can pull it down, up, left, right, or rotate, apply a rotation. So, again, if you were modeling this inside of SolidWorks, you would have to go and specify the no penetration contact for all these faces. And, depending on the rotation and the displacement, I don't know that you would know what faces are going to be coming into contact. Another nice thing here, this model is very, very easily brick meshable. So if we just take a look at the finite element model, and I don't want to spend a lot of time here, but obviously it's a nice, well-structured brick mesh with 3 elements through the thickness. Could have put more elements through the thickness if I wanted to. So, and if you guys don't know, in general, when you're using brick elements, it's a little bit easier numerically on the solver to reach convergence. So that's something that we didn't have in SolidWorks. We were forced to use TETs. TETs are more, a TET mesh you could throw in any geometry, but so having the ability to apply a brick mesh is really, really nice. Let me pull up the results here. I'll point out one other thing. I'm actually using, I think I talked about it in the first few slides. I'm actually using what Abacus calls an H element, which is specifically for hyperelastic materials. It's got an additional degree of freedom. I don't want to get into the weeds, but it's just, one of the advanced capabilities that are available. And obviously I'm using a hyperelastic material model here. I'm using a YAO model. We actually had some test data that we fit to a curve, which is something that's available in structural mechanics engineer with the material calibration. But let me go ahead and play this. And you guys can see, look at the level of distortion that we're getting. And I'm not scaling up I'm not playing games with the deformation scale here. You guys can see the deformation scale set to 1. And we can see, I'm nearly certain that we wouldn't be able to get this level of deformation in SolidWorks simulation. I think the TETs would start to break down. I don't think that we would get there in SolidWorks simulation. So we can take a look at where the contact pressures are starting to build up. And again, you've got full access to all a whole host of results, whether it's principal stresses, plastic strains, all of your deformations, your rotations, and it's very, very easy to create reports, set up sensors, to look at specific results. So I will stop here, and I'm going to kick it over to Michael to show you guys structural mechanics engineer. So Michael, the floor is yours, man.
Thanks, Omar. And actually, I was just using that simulation reviewer role to take a look at some of the results of another study you've been working on. And this gets into the explicit dynamics capability. So, taking a look at a crash test of this Irby riding right into a wall. Of course, we can take a look at how that stresses propagate through and account for those inertial forces. Really understand, from a simple scenario of just like a crash test, well, it's not so simple, but, SIMULIAworks makes it simple and brings that ease of use to some very powerful technology that Omar was talking about. So here's just one example of where structural mechanics engineer really makes it easy to solve for these advanced physics scenarios. So I've got a different example that I'm going to take you through to show off some of the unique capabilities of structural mechanics engineer. We have a Parrot drone, so let's pull this up. And if you've attended one of John and Gian's webinars before, you've seen a lot of the interaction, the collaboration that you have on the platform. Being able to search for items of interest, and in this case I've got that assembly similar to Omar. It was modeled up in SolidWorks, but I can preview it, I can explode it right on the platform, so that makes it easy to dive right dive right in without having to install any software. So here's the drone model that I'm interested in today. Now let's explode this out. You can kind of see one thing that I'm going to show you is this back cover. You can preview the mesh here as well. So we have an assembly process that we're going to take a look at, and also this electronics component. This is actually the GPS circuit board and its mount. As this thing is flying through air, how is it going to respond? At what frequencies are we concerned with, and what's the accelerations and deformations that can occur, and are they going to be problematic or not? Of course, there's other really cool things that we can do, not only cool but powerful and useful. Is what's a crash test look like of this drone model? So like I mentioned before, similar to Omar, this has been modeled up inside SolidWorks, and using 3DEXPERIENCE BLM services, connecting SolidWorks to the platform. I've got access to my entire tree there, and then when I want to create a study, I can just go right here, open up my mechanical scenario app to get started on some of these advanced analyses. So I've done a lot of that already. Let's jump right on in for the sake of time. And take a look at this first one for random vibration. On the left-hand side here, you can see the structural scenario that I've created here. We've got amplitude, we have for my load here, an acceleration-based motion here that is applying that random vibration, and we can take a look at the results here to discover what components are of interest. So this connector got a little bit on the GPS unit there. But what's really powerful here is, since we did a frequency analysis, we can take a look at what this looks like in the frequency domain. So we solved this up to 2 kilohertz, but the area of interest is, just below that 0.5 kilohertz. After that, it's a little bit more structurally sound. So this is where we can refine the model and make improvements to the design to, improve, the displacement or acceleration that happens here. Continuing on, we talked about some of the assembly processes here of the drone. One of them is the back cover, and we can take a slice into the results here, of course, and we can see this snap fit assembly process. And let's animate this as well. And this is where we're really, leveraging the power of that explicit dynamic study type to make the solve really, really easy. I mean, we specified some translation to the components of the assembly, did that general contact, and that was about it. So we let it solve and run, and we can even see, some of the plastic deformation here that Omar was talking about left inside, that clip. So is this something that could be disassembled and reassembled for maintenance or service to the drone? We can answer those questions, validating the physical models and, understanding if it's going to break before we even manufacture our first prototype. But how about that drop test that we were talking about as well? Again, the setup here, and with interactions, we have this general contact, and if we want to change the friction coefficient, we just have a contact property there to do so. So really easy, initial velocity applied in this case, some restraints to hold the floor down, and then that explicit dynamics result or study type, and then we're ready to hit solve. One thing that when we do solve, one unique capability that SIMULIAworks brings to the table here is we can actually solve this on the cloud, so leveraging some high performance computing resources. So I can essentially set up the study on my machine, set it to run on the cloud, and shut down my machine for the day or weekend, and then come back in, log in, and pull the results down to my machine to post-process them. So, during this impact, you may be thinking that the highest area of stress may be in that bottom area, or are some of these clips going to disassemble? Well, we can answer these questions and, again, predict the product performance here virtually, identifying the higher stress and the actual opposite bumper of this assembly. I'll let you just enjoy this animation for a second before I move on, because the next exciting thing I want to show you is something that Omar alluded to, was the damage model and like element creation, element death. So if you've taken a look at any other physical testing examples here, we have a tensile stress here, and at some point this is going to break. And this is something that we haven't been able to answer with SolidWorks simulation, but we can with SIMULIAworks and our structural mechanics engineer role. So this leverages, again, the abacus and the advanced capabilities that it brings, including, element birth death. So as we hit a certain stress limit, we can actually have those elements disappear and account for the breaking of this tensile member. So this is just one example that this applies to. Of course, maybe an impact test. as, again, resolving some of the advanced contacts that come in, but how well is the product going to perform? We can, review and solve for these advanced cases. So as Omar talked about advanced materials and behaviors, we can account for that right on the 3DEXPERIENCE platform. All the results that Omar and I have showed here are saved on the cloud. So, I can access them from any device locally with, 3DEXPERIENCE here, as we've seen, as well as the browser-based review tools. So there's a lot of information here that we haven't been able to cover today. So this is just a little bit of a taste. So where can you go to learn more? You can head on over to solidworks.com/SIMULIAworks. Catch some white papers, some real-world applications here, and how some of our customers have put this into practice. You can also go to My SolidWorks to get a little bit more of a technical deep dive and how some of this technology is working and how you can put it into practice, and understand a little bit more of how that relationship with SolidWorks goes, and as you make a change in SolidWorks, how it propagates back into these SIMULIAworks apps and roles. And of course, lastly, you can reach out to your SolidWorks value-added reseller so that they can talk with you and work with you and understand the types of scenarios that you are, trying to accomplish with improving the performance of your product. So, John and Gian, thank you for having Omar and I here today to talk about what SIMULIAworks is bringing to the world of product design engineers and helping them improve their products.
Well, thank you, Michael, and thank you, Omar. That was really awesome. I mean, just by exploring the physics in a variety of different scenarios, you guys use both structural performance engineer and structural mechanics engineer. And we just got a small taste of how powerful these solvers really are. So if you're at all interested in learning more, again, go to solidworks.com/SIMULIAworks. And also feel free to reach out to your SolidWorks value-added reseller as well. And if you're interested in getting your hands on the modeling tools available on the 3DEXPERIENCE platform, which are entirely cloud-based, we also have a link in the chat, and we'll send out a link to both of these in the follow-up email as well. We do want to be respectful of your time. We realize that our time is almost up, but if you do have time to stick around for questions, you're definitely not going to want to miss these. And before we do that, we definitely want to launch a survey to get your feedback to see what you would like to see on the next episode of Exploring 3DEXPERIENCE Works Live. So while you answer that survey question, we're just going to jump right into some questions. Gian, do we have any questions available?
Yeah, it looks like our first one is just asking if you can use data from other CAD software with the SIMULIAworks portfolio. Should be an easy one.
Yeah, I can take that one. Michael, you can let me know if I'm wrong, or any John or Gian. Yeah, so we can. You can write out a neutral format, so a step or an IGES file, and import that directly into the platform. I mean, I don't know why you'd want to use any other CAD package than SolidWorks, but I guess if you want to.
Yeah, I think I'll just add there, Omar, we showed the data that we were solving today was created inside SolidWorks, and connecting SolidWorks to the platform. It's just the models are readily available for us to create these simulations. But if you're if you're using XDesign or XShape, John and Gian, I know you've done a lot of webinars already covering those design tools, those cloud-based, browser-based design tools. Yeah, that data that's created there is natively stored on the platform, and we can create simulation studies there.
Beautiful. Beautiful. Looks like our next question is just asking which roles were being used for each scenario. So I know we mentioned those, but maybe just reiterate what each of you guys were using, Omar and Michael.
Yeah, so for the stuff I was doing, it was structural performance engineer. It was all steady state. And then Michael was using structural mechanics engineer, which does the dynamic stuff.
Right. Yep.
Perfect. Looks like we have one more question on here, just asking if there is CFD and flow simulation on the platform.
Oh, great question. So again, I'm glad that question was brought up, and you guys saw that slide I had towards the beginning with all the acquisitions that kind of Simulia has done. So right now there is not a role on the platform. In July, there will be a role that a fluids dynamic role that's available on the platform. So yeah, it's coming. And again, utilizing cloud computing for flow analysis is going to be, again, one of the real advantages of that role, right? Because with the desktop flow solver, which is great, you kind of hit diminishing returns after like 6 or 8 cores. You're not going to see that with this tool. You're going to get really linear returns as you start adding cores. So 32, 64 cores, you're going to get with some really fast runtimes.
Right, makes sense to me.
Excellent. Well, that pretty much wraps it up for questions and pretty much wraps it up for Exploring 3D ExperienceWorks Live today. Thank you everybody who attended, and we hope you learned something, because that's what it's really all about. We'll see you guys next time, the same time, 11:30 Eastern time on Monday, June 15th. Again, if you want to sign up for a free trial of the 3D Experience platform, links in the chat. We'll send up a follow-up email. Thank you guys very much. Have a good day.
Thank you.